Hi, I'm Dr. De Bruin, and this is a quick walkthrough of how to answer an exam question from the equilibrium topic of AQA A-level Chemistry. A solution containing 0.8 moles of P is added to a solution containing 0.7 moles of Q. The amount of R formed at equilibrium is 0.24 moles. Deduce the amount in moles of P and Q in this mixture at equilibrium. Now, if I had a bit more room, I would draw myself out a full ice table, but I haven't given myself very much space on this slide. So I'm just going to do it shorthanded margins and things instead. So I can see that since I've started out with no R at all, and I've now got 0.24 moles, R has increased by 0.24 moles. And what I can then do is use my coefficients in my symbol equation to see, well, for every 1 mole of R, how much P and Q was used up. And the answer is that for every 2 moles of R, I've used up 1 mole of P. So in other words, half the amount. So for the 0.24 moles of R that I've gained, I must have lost 0.12 moles of P. And then I'm using 3 times more Q than P. So that's going to be, I'm losing 0.36 moles there. So then if I put these numbers together with my initial moles from the question, then I can find out that at equilibrium, I've got 0.68 moles of P, and I've still got 0.34 moles of Q. My next thing is that I need to provide an expression. So the way that a Kc expression works is that I've got square brackets for concentration, my products are going on the top of the fraction, and I'm using the coefficients as my powers. So R is squared because there's 2 moles of R in that symbol equation, and Q is to the power of 3 because there are 3 moles of Q in that symbol equation. Describe the effect, if any, of decreasing the temperature on the value of Kc. Well, actually, I know that temperature is the only thing that's going to affect the value of Kc. Other things will cause the equilibrium to shift, but the value of Kc will remain the same. But temperature will have an impact. So now I need to look at that delta H value they've given me and work out whether the reaction is exothermic or endothermic. I can see that it's a negative value, which tells me that this is an exothermic reaction. And so if we have an exothermic reaction, then decreasing the temperature is going to favour that forward reaction and therefore increase the yield. So therefore, the number on the top of my fraction is going to be getting bigger, and meanwhile the number on the bottom of my fraction is going to be getting smaller as equilibrium moves to the right. So since I have more R produced, I'm going to have a larger value for Kc. And then finally, in another mixture at equilibrium, I have a concentration for P of 0.88 and a concentration for Q of 0.46. And I've got a value of Kc, which is 2.92, and I need to calculate R. So the first thing I'm going to do is I'm going to get my Kc expression that I already wrote and substitute in all those numbers that I was given in the question. Then I'm going to multiply both sides of my equation by the denominator of my fraction. So this is going to give me R squared, and then if I evaluate that and square root it, I get an answer for R of a concentration of 0.50. They've told me to give my answer to an appropriate number of significant figures, and if I look, all of the numbers that I've been given in the question are to 2 significant figures, so therefore I'm going to do exactly the same thing. Thank you very much for watching, and I hope you found this a useful run through. If you are finding the videos useful, then don't forget to like, subscribe, comment and share the channel, and I'll be back soon with some more A-level chemistry walkthroughs.